Hello kids, this is Mr. Murray. First of all, let me say I hope everybody is doing all right. And secondly, I'm trying this out, so I'm sorry if you thought you had a break from the sound of my voice for a few weeks, but we're going to give this a shot to give a little review here. So we're going to take a look at what we were looking at last week, which was applying quadratic functions and their graphs, which are called parabolas, to word problems essentially. And one of the biggest applications of them is objects in free fall and gravity pulling it back down to Earth. So in this example, which you can find on the website, we have Mo launches a water balloon from the balcony of his hotel, and the water balloon goes up and it comes back down and hits the ground below. The height of the balloon after t seconds is modeled by this function. H of t equals negative 16t squared plus 64t plus 192. What is the height of Mo's hotel balcony? That's what we're looking for in part A. And that would be essentially asking, where did this start from? What was the initial height of this water balloon? Or in other words, when you're looking at the graph, what is the y-intercept of it? Or what was its height at time 0? That's how we always find a y-intercept. We plug in 0 for x, or in this case t, and when I plug in 0 into this, all these parts drop out. They become 0, 0, 192. So h of 0 is 192, or in other words, the height of his balcony, or the initial height of the water balloon, is 192 feet. So I'm just going to label that here as we find these things. I'm going to mark up this graph so we can visualize what we're finding. Part B, what is the height of the balloon after 5 seconds? And the way this function works is it will give you the height after any given time. All you've got to do is plug that time into the function. So if I want to know the height after 5 seconds, I'm going to plug 5 in for t. So h of 5 is, and you can do this by hand, or I'm going to plug it into my calculator. I'm sure you'll all like to do it by hand though. Let's see, negative 16 times 5 squared plus 64 times 5 plus 192. If you're using your calculator or if you're doing it by hand, just watch your parentheses and your order of operations. Okay, so we got h of 5 is 112, and that would be feet. The height after 5 seconds is 112 feet. And so that you can see that that's lower than we started at, which tells me that must be somewhere right around here, because we started at a height of 192, and so just for visualization, we must be right around there, 5, 112. Okay, at this point, if you want the real classroom experience, if you want to find a window to stare out of, or if you want to take a bathroom break, period 5, feel free to, live out those fantasies. You can stare at the clock if you like. It's all a good time. Part C, after how many seconds does the balloon reach its maximum height? Its maximum height, whenever it refers to maximum or minimum, we're talking about the vertex of the parabola. And in this case, after how many seconds? So I'm looking for the x-coordinate, essentially, because the x-axis is time in this problem and the y-axis is height. So how do I find the x-coordinate of a vertex? That's where we have that little mini formula that really just needs to be memorized. X is equal to negative b over 2a. And in this problem, remember, it's in standard form, so negative b would be negative 64 over 2 times a. A is negative 16, that leading coefficient. We get negative 64 over negative 32, which equals positive 2. So that tells me after 2 seconds, this water balloon reaches its maximum height. That's the x coordinate of the vertex there. Part D, what is the maximum height reached by the water balloon? So if it's asking for the height at that time, it's asking for the y-coordinate of the vertex. So again, if I want the height at a given time, I plug that time into this function. So h of 2 will be negative 16 times 2 squared plus 64 times 2 plus 192. Do it by hand or in your calculator. If you're using your calculator, you can just bring back the last step, change that 5 to a 2. You get 256. Feet. Okay, so we have that the maximum height occurs at 2 seconds, and the maximum height is 256 feet, x-coordinate and y-coordinate. And here is another kind of popular question with these. Find the time when it hits the ground. You know, how long is it in the air for? And so it starts here, it goes up, it comes back down, and here's the point where it hits the ground, and I want to know basically how long does it take to do that. Now I can already see that after 5 seconds it's at a height of 112, so it might be 6 or 7 or 7.5, 6.5, I don't know, but it should be around that ballpark. And I want to know what is that value? We plug in 0 for y. That's how we find the zeros or the x-intercepts or the roots of a function. So when I set this entire function equal to 0, 0 equals negative 16t squared plus 64t plus 192. Okay, solving a nonlinear equation equal to 0. I'm going to try to do this by factoring. First thing I look for when I factor is GCF. What can I take out of all three terms? 16 goes into all three, and since the leading coefficient's negative, I'm going to take out negative 16. When I take out negative 16, it's going to cause these signs to change, so just be careful. So that'll be negative 16 on the outside, t squared, that'll be minus 4t, because negative 16 times negative 4 gives you positive 64. And here it's going to give you negative 192 divided by 16 is 12. And so now we've taken out that GCF. We want to look at this trinomial. Can this factor further? It's a trinomial that starts with t squared. If it factors, we're going to use our unfoil method here where it starts with t squared, so it allows me to go t and t, and what two numbers multiply to be negative 12 but add up to be negative 4? Negative 6 and positive 2. And then we factored it. It's all equal to 0. So if this times this times this equals 0, then one or all of these factors have to equal 0. So we set each factor equal to 0 and solve. So t plus 2 equals 0, or in other words, t is equal to negative 2. T minus 6 is equal to 0, or in other words, t is equal to 6. And of course, this constant I factored out, it doesn't have a variable, so it doesn't yield a solution. You can kind of just ignore it there. You have two solutions, remember, because it is degree 2, but only one of them is the solution in this problem because we're not dealing with negative time. We're asking how long did it take to hit the ground, so you have to think about what logically makes sense. So our only answer is positive 6 seconds. Which seems, it was about right based on our initial graph. It seemed like if that was 5, this might be 6 or 7, or in that neighborhood. Okay, so the final part here, we're kind of covering a lot of different little things that can be asked with this sort of problem. Just straighten out that. There we go. Find the average velocity in feet per second of the balloon over the interval from t equals 3 to t equals 5 seconds. T equals 3 to t equals 5 seconds. Now you'll do a lot with this kind of stuff in physics down the road. Lots of math in there, so I'm sure you'll love that class. But basically, velocity is very similar to speed. Notice it's feet per second. So we're essentially asking how far did this balloon travel between 3 and 5 seconds. The only difference with velocity is you'll find is it has a direction to it, but don't worry too much about that right now. But basically, this is average rate of change, which we've done, and rate of change is just slope, y2 minus y1 over x2 minus x1. But to do it, you got to know, all right, at 3, where was this balloon, and at 5, where was the balloon? You got to find the height at those values so you can do the slope. At 5, we've actually already found that back in part B here. At 5, the y-coordinate was 112, so I could save myself a little time if you're paying attention. And you know that at 5, it's at a height of 112 feet. At 3 seconds, we don't have that. That's one of the only ones we don't have on this, really. So that is somewhere around here, but I'm going to find it by using the same function. H of 3 is equal to negative 16 times 3 squared plus 64 times 3 plus 192. Go back to my old buddy, the calculator. Bring this back, change the 2 to a 3, or retype it out, or do it in your head, whatever gets it going for you. And we have that it's 240. So the height at 3 is 240. 240 feet, that is. So now I know the two coordinates. At 3, it's at a height of 240. At 5, it's at a height of 112. So when I do the slope, or the average rate of change between those 2 points, you're doing y2 minus y1, 112 minus 240, over x2 minus x1. And I think it's important, or might help you understand it if you think about these units. 112 feet minus 240 feet is a difference of negative 128 feet. That represents that the balloon lost the negative. It dropped 128 feet during this time interval. But if you want to talk about speed, you need to know, well, how long did it take to do it? Well, this is 5 minus 3, which is 2, and those represent seconds, the x-coordinates, the x values. So it lost 128 feet over the span of 2 seconds, and that is a rate of change of negative 64 feet per second. And there we go. All right, kids, I hope all is well, and feel free to email me if you have any questions with this homework or any other homework. And, have fun. Hope all is well. Be safe, be healthy, and I'll see you soon, hopefully. Bye-bye.